Değerli misafirlerimiz, tekrar merhabalar. Daha az karbon emisyonu üreten, daha sürdürülebilir ve bunun sonucunda dünya için maliyeti olmayan projeler üretmeyi ilke edinmiş olan Buro Happolt'tan Orta Doğu Bölgesi Sürdürülebilirlik Takım Lideri Dr. Robert Cook ve Londra Bölgesi Portföy Strateji Yönetmeni Hugh Mulcahy, sürdürülebilir proje tasarlama stratejileri başlığındaki ortak sunumlarını gerçekleştirmek üzere kendilerini sahneye davet etmiştik. Önceden yerlerini aldılar. Sizlere keyifli bir söyleşi ve konferans sonu diliyorum. Teşekkürler.
Thank you, Neslihan. Good evening, everybody. It's ready to begin. Okay, so my name's Dr. Robert Cook from Buro Happold, and together with my colleague Hugh Mulcahy, going to talk a little bit more about sustainable design. We heard some fantastic things earlier this afternoon about some new technologies using LEED, about the value or cost of green buildings. And hopefully we can build upon some of those thoughts. So just quickly start off with a very brief description of Buro Happold. So we were formed about 35 years ago by Professor Sir Edmund Ted Happold in Bath in the UK. And Ted formed a partnership which was actually formed based on Quaker principles of peace and fairness and equity. And a lot of the early work was based around very low impact materials, very light tensile fabrics. And the principles that were laid down when Ted started this very small practice 35 years ago are still flowing through the company now. We have a great affinity for research, and we still believe in touching the ground lightly. Buro Happold in that time has spread to around 1,500 staff across the globe. And we hope for continued success. Now, I'll start off this presentation back at the beginning. Economic theory is largely based on the principle that there are no limits to growth. All economic models that you see for the future are usually based on this principle. In 1972, Meadows wrote a book about the Silent Spring, and there were books around Silent Spring, and Meadows wrote about the limits to growth. And this principle absolutely stands behind everything that we talk about now. There are limits to growth, and we're feeling that now. We're feeling it in economic systems. We're feeling it through our lives. And this has been predicted for some time. This then led onto the definitions of sustainable development that were sort of laid down in the late 80s. And what many people remember as the Brundtland Report. Now at the top, you'll see the statement from Brundtland, the short statement that people remember. Below that is the longer version. And actually the longer version, for me, does a lot more. Things are not going to be straightforward. Painful choices have to be made. Sustainable development rests on political will, and obviously the will of us as people to make that change. So those principles of sustainable development were based around the three pillars that we all know very well. But there's also another definition, and this has been used in the UK by the UK government now, which originally I didn't really understand, and I didn't get a feel for. But now I look at it in a different way. And what I realise about this graph, or this diagram, is that the base of everything, the heart of everything, that everything else is resting on in this diagram is natural capital. Our natural capital doesn't increase. We can use it more efficiently. We can use it in different ways. We can increase the efficiency of our farming methods, we can improve yields from crops, but there are going to be limits to that. And from that natural capital, we can build our social capital, our culture, and things like that, and our human capital, so our personal well-being. Based on those elements, our structures, our organisations, then we can build a financial capital and our manufactured capital. So I think this gives a useful definition, showing us that finance doesn't lead the world. Finance doesn't lead the world. In fact, it sits upon the foundations of the nature and the people within it. So within Borough Happold, obviously, we need to try and use that definition a little bit for ourselves. So hopefully, we hope that our buildings and designs and our solutions can help to enrich people's lives, enhance business, improve the experience and passion that people have within places, and delivering more but using less effectively. And I won't go into these points. There's a lot of different factors around sustainable design. You see there a long list around environmental resources that we need to consider. Our social needs are great, and we should never design a green building at the expense, perhaps, of social needs. And we need to consider all of those aspects. You'll see in these slides that I mention the needs, but also what the risks are if we get things wrong. And also we have the economic considerations. Now, the benefit of all this and this definition is that it spreads from the smallest technical component through a building, through your communities, through a region, through an organisation. And if you get sustainable development right, you can apply it in all of these ways. And hopefully I'll show an illustration of some of that today. There was a concept earlier about cradle to cradle. This touches on cradle to grave. But we can, again, use the concept throughout every stage of the building design, from all our research and our thinking to the development to the construction management, through to operation and use. It needs to be intrinsic throughout. And then again, there's another spread here, in another spectrum. So here we have the human needs, all the way through to the technologies, and all of those different aspects in there need to be considered. And sometimes you get a specific product and that just it sits in one place, or a specific idea and that sits in one place. You need to see the system as a whole. You can't just see it as an individual technology or approach. Now, okay, why are we doing this? So I just want to touch on the last year. In the last year, we've seen record increases of global primary energy consumption. To me, this is astounding. We're still increasing at a faster rate, our consumption, during recession. And with a lot more education and awareness. So it's clear that we need to do a lot more across the globe. There's record increases this year in greenhouse gas emissions. They've gone up. The recent results came out in the last couple of weeks, and they've increased far greater than in the previous years. And we've seen impacts of this now in our own world. The Arctic melt of the Northwest Passage, the unpassable place in Earth, it's now possible that you can circumnavigate the Northwest Passage. So this was touched on earlier very well, but why is this? We've got a situation in the world where we've got a reducing global biocapacity. The ability of the Earth to accept us and receive us and do all its natural processes is reducing. We are reducing it. At the same time, we are increasing our ecological footprint, and there's obviously a direct link between the two. A couple of years ago, we passed the point of what they would call sort of the no return, where our consumption exceeded the ability of the Earth to maintain us. So we look at these two graphs of the world. The one at the top is from 1970. This illustrates, the green illustrates where there is an excess of biocapacity, and a deficit in the footprint. So where your footprint is low and your biocapacity is high. So you can see there in 1970 we were happy. We had more biocapacity than we were consuming. The one at the bottom is 2008, where the biocapacity is far lower than the consumption. And in some regions, it's extremely extreme. Including in that, you can see the UK and places like Saudi Arabia and Dubai, and UAE. So this chart here looks at Asia and Turkey. So the graph on the top left shows the difference in Asia between consumption on the left and capacity on the right. You can see at the bottom two graphs that the consumption on the left is increasing while the biocapacity on the right of Asia is decreasing. They are on slightly different scales. The consumption is much higher than the availability. And the top right is Turkey's own picture. So in approximately 1980, you touched the point where ecological footprint exceeded biocapacity. And you can see that the graph for the biocapacity is steeply downward. Things are not getting better. So they were the reasons for sustainable design, the reasons for really picking up and taking the mantle and making big differences. So I thought it would be useful to touch on some of my own research, which looked at the barriers of sustainable design. And this is some years ago now, probably about 8 years ago. But then cost was seen as a significant barrier. This is what we call a box and whisker plot, where the yellow triangle is the mean result in terms of importance, and the bands show the stretch in the results that were given. You can see that cost was always perceived as going to be a big issue. But you need to recognise that there's a lot of other problems that we face. If we are going to have more sustainable design, we can overcome the cost aspect, and we heard a little bit of that before, but we also have to overcome perception of risk, ignorance and lack of knowledge, a perception that the technologies and techniques are unproven, where planning and policy issues often get in the way, considerations around maintenance of these new technologies, the perception that these technologies and projects are complex, poor communication, stubbornness within the industry, within the contractors in particular. And so you can, even if you took cost out of that equation, you can still see why it's very slow. It can be very slow to move and make real progress. And I've seen for myself on projects where the costs stack up, these technologies or techniques may still not work because of the lack of awareness or the other social barriers that are in place. So we all have a part to play in that. This is some slightly more recent research, which is also supported by myself, looking at the barriers that we face in terms of sustainable design. And you can see there that there's a lot, the barriers across the industry are many, but also they're interrelated. And basically, it's a complex situation. We have to get through this complexity. To do that, we have to be very strong. We need to build up a great big body of knowledge, and we need to work together. Now, what is sustainable? So I want to give an example of a building I see nearly every day in Abu Dhabi in the United Arab Emirates. This building is put forward by the architects as being highly sustainable and being optimized. This building has a particular innovation. This is halfway through construction, and it's a glass building, fully glazed in the desert, with very little light control on the glazing. But then what they've done is they've added this adaptable mashrabiyah on top. So each of these units is an umbrella. And if you close the umbrella, you let the light in. If you open the umbrella, it closes the light out. Now, in one way, that's an interesting idea, because as the sun comes around the building, these umbrellas will open and close, and it will change the shape and the view of the building and prevent the people from having unwanted glare and solar heat transfer. However, the architects designed the building and they're not regular in plan. So they're not a circular building, they're slightly curved, oval. And that means that every single one of those umbrellas is unique. It's completely different to the one next to it. So every single one is bespoke and had to be made separately by hand in China. And they were made to such quality and detail that they could only be made by the Air Force, the Chinese Air Force, who make the jet planes. And these are higher quality components that are in a jet than in a jet plane, an aeroplane. And for me, this is the wrong perspective on sustainability. I can tell you that this building did cost more than a normal building, but it's not a green building, in my eyes. For me, you really need to go back to the more holistic list of considerations for sustainability. Don't get focusing on one particular point like the shading and ignore the rest. So we always try and take an approach where we look at the whole in terms of the situation, in terms of the design. So I'll go through each of these in a little bit more detail. So just in terms of materials, I think people touched on it earlier today, but you can see there that there's a lot of consideration just around materials. Should we use natural biodegradable materials? Should we use specific reuse of materials? Should we look at the life cycle assessment of the materials? Should we be looking at the cradle-to-cradle approach and looking at whether or not we can recycle materials? There's a lot of considerations just around that one aspect. There's a massive industry just around there. Carbon reduction, I'm sure everyone is aware of the many sort of techniques. We heard earlier about the passive design. So understanding the microclimate impacts, the importance of orientation and massing of a building can have a big impact. That can have a very large impact on the actual energy use and how it works passively. Through active systems, to generation of energy from renewable energy sources. Even thinking about the carbon reduction around the transport to get to those buildings and providing a walkable community that those buildings will sit in. In order to improve our carbon reductions, improve them, we can do a lot of detailed modelling. We heard about daylight modelling and thermal modelling and optimisation. We can also use post-occupancy evaluation tools where we're going back into buildings and evaluating. In terms of transport, I just thought I'd put up this slide again. Transport's a big issue that you should really be considering in terms of sustainable design of cities, communities, and where you site buildings. And this graph shows some research done in Houston, where Houston have got this horrible problem of it's so expensive for people to live there in order to get to work. And they've got this huge carbon impact, and they don't understand how they're going to reduce that. But if you look at the design of their city, the design of their city means that they've got this huge transport-related energy consumption. Now, those cities are there for a long time. You can imagine the carbon footprint that they're going to have compared to cities at the bottom there, so Singapore, Tokyo, Moscow, and some of the European cities. We also have to think about adaptation. If climate change occurs, we're going to have to design our buildings in order to accord with that. So really, we ought to be implementing as much passive design as possible so that if there are more extreme weather events, that those buildings are resilient to those changes. We also need to think about adapting to different uses. In a lot of European countries, there's an aging population. So some buildings that might be schools today in the future might need to be other uses. Because if the buildings we have today and the uses we have for them become obsolete, are you just going to demolish those buildings and then put a different building? So you might have to look at the design of buildings in a different way so that they can be more flexible. We also need to adapt buildings more to user requirements. and as I said, make them more resilient. The diagram at the bottom is particularly of use in the Middle East, where you don't have to air condition every space. But if you deal with a space passively, you can actually provide comfortable semi-external or semi-internal environments for people to use that aren't fully air conditioned, so they're efficient, but are still comfortable for use by providing adequate shading and cross ventilation. You can go into detail around climate adaptation and resilience, and you can look at the wind effects around a building and how to maximize wind effects. And there's lots of things that consultants like Bura Happold can do. In some way, you don't have to do all of them, and I don't think a sustainable building is necessarily one that's had 1,000 models made on it. If you get the concepts right at the start, then I think you can comfortably move on without too much detail. It's only really when you start building a very complicated building or an architecturally fascinating building, perhaps, that you need some of the more detailed modelling, in my view. Now, you can't read the text on this slide, and I make no apology. Again, this slide is meant to show complexity. One of my PhD students has been looking at water systems and how to develop more sustainable water systems. So they looked at the existing water industry and what drivers there are for having a more sustainable system, what would need to be done in order to create a more sustainable water system. This convoluted route, where there's no beginning and there's no end, this is the route to a more sustainable water system, in particular looking in the UK. This is highlighting where there's barriers from industry or from government or from the user. So unfortunately, all it shows us is it's highly complex. And the problem we've got is we've created these very complex organizations and problems for ourselves. And now we need to make significant change. We need to make step change around water use. And yet, we actually all find it very hard to do it. And luckily, this sort of summarizes some of that. So there's a point towards the bottom there saying that water underpins the key global initiatives such as the Millennium Development Goals. But since those goals were established, there's been no improvement. None of those goals have been achieved. And we need to really be pushing the boundaries of what we do, and we need to consider concepts such as water footprinting. Now, I don't know, this is a relatively new concept, but when you buy, for instance, a bottle of Coca-Cola, that bottle of Coca-Cola, perhaps it's 1 litre, doesn't have 1 litre of water in it. It probably took 10 or 20 litres of water to create it. And that is the same for building products such as bricks, as steel, as concrete. They all have a water footprint, and that's taking up some of our valuable aquifers and water resources. And that's obviously another broad issue that we need to take in mind. There's some research looking at many cities around the world in terms of how they perform from a business perspective. And I took this snippet this is from the PwC. And in there they have a sustainability category. And you'll see that Istanbul is 16 out of 26. And the higher the score, the better. So it's in the middle for sustainability. You see that Abu Dhabi, where I live, is on the lowest. So I'm trying to do my best to improve it. But the one thing that it shows that Istanbul is very poor at, the second worst out of all the cities, is waste recycling. Now, I don't know why in this list you're the second worst at waste recycling in Istanbul. But clearly that's something that needs to change, and potentially that's around infrastructure and the infrastructure that's provided to you and the way that you treat waste. So in all of the buildings you're designing, really need to be considering putting in sufficient waste infrastructure that in the future people can easily recycle waste. I won't touch on this much, but biodiversity and habitat protection is an issue that they don't think very highly of in the Middle East. But actually, even there, it's a very critical component, and that's part of the global biocapacity. One of the topics is employment and education. This, for me, is a significant part within sustainable development. The comment was made earlier about a building might have a LEED rating, but please tell us what elements were within that LEED rating. Give the education element as well as the advertising element. Make things explicit and clear to people what measures you took and why, and how they can learn. We need to be teaching in the schools and building schools or retrofitting schools that are more efficient and showing the kids that they're the way of the future. I mean, there's also the point here about employment. There's to talk about green jobs. And there's also this consideration that every piece of oil, every unit of oil you buy, 70% of that money, or every unit of energy you buy, 70% is from overseas. So your hard-earned money is going out of the country to somewhere else. And so that is losing potential for employment. The financial aspects need to be considered, and Hugh is an expert in that area, so we'll talk more. But recognizing value of buildings. There are cities in the US, such as St. Louis and Detroit, which are virtually empty. Some of the downtown areas that were once full of people that had high building values, high land values, are now empty of people. The buildings are being dismantled brick by brick, and they're being sold because they're more valuable as the components than they are as a building. And that has become because they were not in sustainable cities. The infrastructure wasn't there for a sustainable city. They didn't have the transport systems. They didn't have the education systems. They didn't have the social systems. They didn't have the communities. So we always believe that the price of land will go up because there's going to be more people. But even with increasing populations, cities in the US and in other places in the world are struggling with land values dropping. And then it's very difficult to act. And I think Hugh will touch on this later, but this highlights that a city needs a very broad asset base. It needs to be strong in a lot of different areas, and you shouldn't ignore the soft assets, the people, the societies, the communities, and if people are happy. And moving on to happiness and well-being, this is a very difficult area that a lot of people avoid, and I'm really glad that the physician touched on this earlier. We worked with the New Economics Foundation in the UK, who is a non-governmental organisation, to look at what is the definition of sustainable well-being. And they did a lot of research in very poor estates in London, and they asked the people, what about your communities do you like, and what about your communities don't you like? And they came up with this definition of place happiness. And that's working with the community to establish what makes them happy, what is good about where they live and what's bad about it, and then working with them to improve that. And you can add that also to place sustainability, so the environmental impact, how far it takes to travel places, the methods of travel, and things like that. And you add those together and you can get yourself a definition of sustainable well-being. And there is a technique now, this process chart shows the way for designing a sustainable community which focuses on sustainable well-being. Because if people don't want to live somewhere, they're not happy there, then the values will be low. Obviously, another key point, which has probably been touched on before, is about land, food, and population. The graph there on the top left shows the massive increase in food prices across many different basic food sources in the last 5 years. And that's been relatively sustained. And the problem we have is we don't really see that that's going to come down. And I believe that this is due to the stress that we're putting on our natural capitalism. We really are stretching all of our natural systems. And despite all of the developments since the 1960s in terms of food growing, we still have the same number of nearly 1 billion people on the planet are undernourished. And that's been consistent since 1969. So we need to think through all of this, and for me this is one of the main concepts of sustainable development, is today or tomorrow. We talked about, is a building more expensive? Which way are you looking at it? Are you looking at it today or tomorrow? In the UK, they've changed the regulation, so there is now, it's far more important to have a BREEAM assessment, and there's the Code for Sustainable Homes that is compulsory. And for a long time, people avoided these systems, or they went for the minimum measure. In the last 3 years, you go to a developer and they said, I want the best one. I want the excellent rating. I want to be the best. And the main reason for this is because they see this as quality. There aren't many quality marks within the building industry. How many quality marks do you see on a building when you walk in? Is this good quality building? When you buy a building, when you rent a building. So the BREEAM assessment or the LEED assessment can be one of those quality marks, and that can be important. The same was seen with white goods. With white goods, when they brought out the rating system, the ABCD, everyone went for the A. No one bought a B. No one bought a C. And the industry could not believe it, because before they introduced that, people didn't care. Why? Because people wanted the A. They wanted the best. And they perceived that that would last longer and would be better. Throughout this process, you can talk about one of these things at a time, but what we would suggest is to really try and apply integrated thinking. So in a system, you know that you have demands. The demands are at the bottom. So a building needs hot water, it needs cold water, it needs perhaps cooling and heating and electricity. And then you can look at the resources above, and you can look at where there's potentials for symbiosis. When we're designing or looking at new cities and new master plans, we're looking at it in the way of, instead of looking at it as a linear city, so you put things into the city and then they go out as waste, you actually look at it as a circular economy, thinking about keeping the goods, the services inside that economy. That's good from an economic perspective. And it's also good from a reducing waste perspective and being more efficient. And this is a lovely story of someone that had some waste cardboard and they didn't know what to do with it. So they sold it and they used it as horse bedding. That horse bedding went to soil to create worms. Those worms were fed to sturgeon that created caviar. So you've got something that's a waste product, and you've created something that is a very valuable product. And I know that this is a very simple analogy, but there are many of these systems. And the speaker earlier talked about nature and learning from nature. And there are many ways that you can look at natural systems and how they recycle and reuse things, and realize that there's inspiration for us all for making more money and more value from what at the moment we see as waste, and changing our ways. So I think I'm nearly done. I'm going to click onto the next slide and find out before I introduce you. But wait there, Hugh. So really, this was a green office building's definition: efficient resource use, human health and environment, considering the life cycles. Sorry, I'm not finished, Hugh. I changed the slides. I wanted to touch on environmental rating systems because I know that that's something that you're trying to introduce here. There are many systems around the world. There's a whole basket of systems you can choose. Now, all of those rating systems are different. They all have a different emphasis. And we've looked at the BREEAM, the LEED, and other systems. Some of them have more of a definition, more of a focus on sustainable sites, on the location of your buildings. Others look more specifically at energy. And for instance, in the Middle East, the systems there look more at water. And the one system that's been developed in Abu Dhabi and implemented in the last 2 years, and we've been helping to write Estidama and implement it. And it's been a very interesting process, so I'll hopefully talk to some people about that later. It's made a really, really big difference in Abu Dhabi. They didn't have anything before, And Estidama is mandatory. It is now part of their regulations. So in one foul swoop, it is made regulation. Now, in one way, that has changed the whole industry for the better. But in another way, it's been very difficult for people like contractors and suppliers to adapt and change. So you do need to consider the capacity within your country, within the experts and engineers and architects and contractors. Have they got the capacity in order to take on such a large change? Now, I'll briefly touch on Estidama because I think it's interesting. They look at a community scale down to a villa scale and look at buildings. And their system, again, like many of the others, looks at natural systems, whether or not buildings are good quality and livable, looks at a lot about water, energy, materials, but it also looks at this integrated development process, and I think, again, this was touched on before. This is a breakdown of the optional credits, and so you can see there's an emphasis on water, but there's also required credits, and they're mandatory now within the regulations. And I'll touch on some important ones within that. One of those is outdoor thermal comfort. It is now mandatory within Abu Dhabi to provide shade in outdoor areas for people to allow them to walk. Now, before this was the case, you can't walk around Abu Dhabi in the summer. It's very difficult. You'll be lucky if you can find a pavement. Now, with this regulation, there's pavements and they're all shaded. And this is making a big change to the way people will get around the city and their environmental footprint. They also have an interesting perception on water because they don't have specific measures you must do. They say that you must create a water balance. So you look at your internal systems and make them as efficient as possible. And then the water that you have from that, you recycle as much as possible. So if you want heat rejection from water, if you want to irrigate plants, you have to use the recycled water. You can't use potable water from the tap for irrigation or heat rejection or water features. And this is really important. It gives the architects and engineers flexibility, but at the same time prevents waste. And I think this is pretty much a summary of the earlier slide, but you can see that different rating systems have a different emphasis on energy or water, and it's important when looking at a project to consider those. I listed around 12 headings earlier on, and then talked through each one. Those 12 headings are roughly in that pie chart there. And you can see, for instance, this is BREEAM. So looking at BREEAM, if you were to say, I've got a BREEAM building, it is the most sustainable. Or if I've got a LEED-rated building, it's the most sustainable. It's not necessarily. What I would encourage you all to do is to look at every project differently, to think about what your client needs, what your community needs, and think about what your definition of sustainability is. Where do you want an emphasis? Because otherwise, you'll place an emphasis on areas using BREEAM and LEED that perhaps aren't the most sustainable for you in the roundest sense. So I would encourage you to apply visioning to establish what your values and needs are, and then apply the likes of LEED, Estidama, and BREEAM. This is where we work with the client, and we had overlaid the client's needs and the brief with the BREEAM and sort of sustainable development chart. So you can see here that there's different client drivers, there's different policy drivers, and there's different project drivers from the project team. And you can balance those across with something like BREEAM. And then from that, if you want, you can develop a bespoke system, which we call a sustainability framework. All of this really applies for every scale of building. The way I'd like to see it is really as a process. So the most important thing is to understand the context of the building you're looking at, understand what your definition of sustainability is, what your needs are, where do you want the balance, where's the opportunities, and where's the constraints. So understand that context, and then move through the process, trying to maintain a holistic design approach, taking on board all those wide and diverse issues. Then perform the detailed analysis where it's necessary. and then undertake a process of reviewing that work through post-occupancy evaluation. This is another slide on context, so I won't touch on that. So I think at that point I'll hand over to Hugh.
So my name's Hugh Mulcahy. I'm Director of Asset Strategy at Happel Consulting. Happel Consulting is a small but perfectly formed part of Buro Happold that doesn't have any engineers. We concentrate on business consulting and economics, and which of course I think is very important. My first slide relates to project failure. A bit of context. In the UK, we've been in a recession for quite a long time now. There's quite a lot of failure about. There's oversupply of offices in the market. A lot of emerging economies aren't so familiar with that. And there's something like £100 billion worth of bad commercial property debt at the moment that needs to be refinanced by 2013. So there's quite a lot of worried people trying to work out what to do with their real estate assets and trying not to make mistakes in the future. We've been looking at failed projects, and there's a lot of them, and we think the main reason for failed projects isn't usually technical. It's usually a misconception of what's wanted. And the main misconception, from my point of view, is that people seldom think about who's using the buildings. And the people that are using the buildings are called occupiers. The people developing them, the developers and the investors, in the UK at least, seem to become very disconnected from those occupiers. So I'm just going to raise three main points. One is, are buildings for occupiers, which may be self-answering. I'm going to look at what consumes most energy. And I'm going to just touch on the subject. So should we be looking at green buildings or green locations? In Happel Consulting, when we look at our approach to asset strategy, we try and look at a holistic approach. We look at people first. Real estate does come in, it is important. But we're also including technology. And very importantly, how the organization itself works. And because we're economists and business strategists, we know that money is actually quite important. The occupiers at the moment are facing some difficult choices. In the UK, they actually have a lot of real estate. They know they have a lot more than they need, and they know they've got lots of choices in the market. So we're helping them make some of those choices. And our approach to it is to go through things looking at whole life cost. And from extensive modeling, which I've been doing over the last 15 years or so, most of our data is fairly consistent if you look at the whole life cost of occupying a building. For every pound you spend on the building, broadly whether you own it or whether you rent it, you're probably spending around about £5 operating that building over its 25-year life. That in itself focuses people's attention on where maybe the money's going. But what really gets them going is when you look at the people within those buildings. For every pound you spend on building cost over its life, you're probably spending £200 at the upside on the people within those buildings, depending on what they do. And some estimates say it could be as low as £12 over the life of that asset. So organizations are waking up to the fact that focusing just on the building cost, and we had some interesting observations about that before, perhaps isn't really the big issue. The real big issue about sustainability is actually looking at the people within those buildings and making sure that they can lead economically productive and happy time in those buildings. So what are the obstacles to working out what to do next? Well, it's mainly about gathering good data. In the UK, if you ask most people, do they have good data, they say yes, and then you have a look, and you find the answer's no. what we find is that there's reasonable data on new buildings, and lots of discussion today has been about new buildings. But if you're making a decision about what to do next, you need to know where you're starting from. And there's very poor data on performance of older building stock. There's very poor qualitative information on how good that stock is and how it leads to productivity or not. And there's very little comparative data between types of buildings. From the operating perspective, there's almost no reliable, standardized operating data. And it's often based on misleading metrics. If you measure the efficiency of a building per square meter and it's empty, what's that telling you about the efficiency per person? There's some very, very distorting data out there where portfolios are underutilized. There's little grasp in the market about workplace efficiencies. There's a huge range in the amount of space organizations allocate to each worker and whether they actually use it at all themselves. And there's very little information, very poor information around on invest to save decisions. Is it worth spending money on this building? Should we move? What's my payback period? Often decisions about property relocation is made in the absence of this information. And again, there's poor comparative data between types of building and ways of occupation. And there's very, very little data integration, taking disparate data from different sources, for example, on energy costs and other forms of expenditure, and looking them at classes of, together for classes of building. And on the human side, there's a paucity of data on office productivity. What is a productive environment? How do you measure it? And very little integration or utilization of that data. And a vague understanding of social networks. Is it a good idea to put lots of people in the same place, or is it better to keep them apart and make sure they don't talk to each other? And there's fairly poor values for money assessments on those issues. So we attempt to try and solve these problems. And the way we go about it is trying to collate all that data for occupiers across their portfolios. So our starting point is looking at their existing portfolio. There's no point making a decision to move into a lovely, green, modern, efficient building if you don't know where you're starting from. So we seek to gather that data. We seek to gather data on headcount and efficiency and ways of working and organizational design, and then model that over the whole life of the client's portfolio. Only then can we make an informed decision about what kind of solution is the best opportunity to go forward. We believe in evidence-based decision-making. Eventually, we think it's going to catch on. What we find so far is that almost any organization I go to, we find that they're probably using, at peak demand on the busiest day of the week, around about 40% of the space they have. That means 60% of their space is redundant. If you're looking for sustainability, looking for efficiencies, reducing your carbon footprint, and bringing down costs, I suggest that's the first place to start. Working with government, looking at other inefficiencies around building design and ways of working, we're generally able to halve the footprint of portfolios. This enables them to reduce cost. Reducing cost allows them to spend more money on greener, more efficient buildings and drive out further savings. Surplus land is released and put back into the economy. And larger, more efficient, less fragmented portfolios allow for more joined-up, efficient working. I won't bore you with the different kinds of financial analysis we do, but there's a summary cash flow that looks at the cumulative cost of occupation over a number of years. Hitherto, government occupiers in particular were tending to grab at the most cost-effective in the first few years, not realizing that the long-term implications could be different. We also advise them about risk. Our modeling doesn't come out with one answer. It comes out with a range of answers. we try and work to a 90% confidence level and tell them what the best case and the worst case might be. Because the cheapest option, or the apparently best value option, may not always be the lowest risk. We also use regression analysis on our data to try and look at which factors could be changed to reduce cost most. And one interesting finding is it's often not around building costs or technology costs or the kind of building you're delivering. It's actually how you use it. This chart shows on an existing portfolio that the variable that the organization could have changed most, that would have yielded the biggest saving overall over 25 years, was how often people moved desk. How often you move desk, not the design of the building, not the footprint, not the building cost, but how often you move desk. It was costing that organization something like £2,000 a year per move, and 25% of the organization were moving every year over 25 years. We're also looking at issues around social networks. I don't mean things like Facebook and Twitter. I mean how people interact with people in the workplace. We're measuring interconnectivity between teams and looking at the productivity of those teams. And there are some strong correlations between getting teams to actually sit together and work together and the financial outputs of those organizations. We're also helping organizations plan ahead without getting into any detailed design about how they could move peoples and teams around buildings and optimize the efficient use of those buildings on a real-time basis. And we're repurposing some of the engineering capability we've got around people flow analysis to make sure that we can use the buildings as efficiently as possible in the future. 18 months ago, I did a survey of the 30 of the biggest occupiers of commercial office space in London, and it yielded some very interesting results. These were mainly commercial occupiers with a sprinkling of public sector occupiers. I have to say they weren't a very happy group of people 18 months ago. They're in the middle of a recession, which they're still in, and they're having to make some fairly difficult decisions about how to spend money and how to take their organizations forward. And one of the bits of analysis we did was to look at whether the recession was having an impact on their business, which is represented on the horizontal axis, and looking at whether their organization was sensitive to property costs. And we were trying to understand whether organizations were consistent in the way they were reacting. And we found they weren't consistent, that different groups were behaving differently to the recession, that all of them had a different take on what was going on, and you couldn't come to any particular conclusion about how an organization would react to the recession based on who it was, although there were a few trends. From this, we learned that there's no one-size-fits-all when it comes to looking at organizational design and the way space should fit in around them. But we did find out some other things from the survey. One is that they all wanted to be green. They were very, very keen on being green, and they all had corporate social responsibility programs. But they also said that prior to the recession, they were looking for a 3-year payback period, and post-recession, they were looking for a payback period of less than 12 months. So we could see that any decisions to go for green buildings were going to have to make financial sense in their own right first. Moving on to energy consumption, this is some data on who is consuming energy and where. And we can see that there's the forecast is a fairly relentless growth driven by the rest of the world, who are growing even if the UK economy in particular isn't growing. And what's the impact I'm looking at is not a sustainability impact, but an economic impact and an energy scarcity impact. You can see the mere blip that the recession had there, and that the growth in consumption is going up relentlessly. and that although there is some growth in renewables, we're talking about use of fossil fuels, which is a finite resource, and prices have been going up accordingly. This isn't an acceptable risk for most of the businesses that I'm dealing with, and they're having to plan for increased energy scarcity. And energy scarcity, I would contend, also links to other resources that we may not think of as energy-related. We can see that China's demand for steel is pushing up global demand for steel. But in addition to that, there's how steel is priced. I contend is driven by energy. If we look at the trend on the price for coke, the energy components of steel making, and the trend for the price for iron, we can see that there's a 4 times increase in both over the period, and that the correlation between the two is pretty close. I'm not saying there's actually direct cause and effect, but it does look a bit like that. The other issue which is vexing, concerning a lot of occupiers who are clients of mine, is the impact of transport costs and the risks around transport. This chart shows that in the UK we've made some good impact on reducing energy consumption in lots of areas around domestic, industrial, and services, how we use energy. And we've done that consistently against economic growth. The one area where we're failing to reduce energy consumption is in transport. And that is, again, having a huge impact on prices and is becoming quite damaging to parts of the economy. And this brings me on to the next main point I wanted to make, which is about making decisions about where to locate and taking into account not just whether they're green buildings, but whether they're green locations. So what I've done is I've taken a generic building. I've assumed that it was originally designed for 300 occupiers and looked at the CO2 output, outputs for each of those buildings in themselves. And what I've done is looked at an old building that would be in central London, which is generating 75 kilograms per metre squared of CO2, and compared it to one that's a lot more efficient at 25 kilograms per metre squared. And I've also looked at can we use those buildings more efficiently, and I've decided that we could use both buildings more efficiently, and we could bunch up in both of them and reduce the overall CO2 output. I then looked at both of those locations, one's central London, one's outside London in a greenfield setting. I've looked at both of those locations on the basis that how people travel to work. Now, in central London, virtually everyone travels there by train, and I've assumed a national standard journey of 8.2 miles, which is about 13 kilometres. And that adds a carbon footprint to those buildings. I've also done the same calculation for an out-of-town location and looked at the carbon footprint there. And what we find is that the super green building in the out-of-town location has an awful carbon footprint on the basis that you have to drive to get there. If you were to take any action to reduce the carbon footprint of the old, poor-performing building in the centre of town, it could probably exceed the high-performing building out of town. So my main points, to sum up, for my part, are that occupiers are much more concerned about the bottom line than green issues. I mean, it doesn't mean to say they're not concerned about green issues, but money talks. Good asset management leads to sustainable outcomes, and if you manage your assets well, you can afford to spend more on better buildings. Energy shortages are already causing financial pressures, and people are planning on that basis. Transport is a major consumer of energy resources, and one of the asset value shifts, we were talking about asset values before, one of the asset value shifts that's already being exhibited in London is that out-of-town business parks are not holding their value, and central locations within the town that's well connected to transport nodes are holding their value and are increasing their value. Good location planning leads to greener, better value outcomes. And finally, assets close to good transport nodes are more likely to hold on to that value. And we see that trend accelerating over time. One of my big corporate clients, a pharmaceutical company, is working with us to move out of their very extensive business park locations, which are quite new, into more central locations where they can maximize density and reduce the dependence on the car. And I think that's a sign of things to come. Thank you. Back to Rob.
Thanks, Hugh. Taking this, again, a bit broader and looking more at green buildings, I've just got the last 15 minutes. You really need to think about people's values. What do they value? What looks like good value? So for this example, this was a school, and we took different people within the school and the design team from an architectural practice and asked them about their values. So we did a survey about what they valued, and this was prior to doing any design work. And you come up with a very crazy chart like this. And what you realize is that values are very important, and values for people are very different. And when we work as a team, and we're trying to work as an integrated team, you assume that you know what the client's values are. You assume you know what the architect's values are. And when you're drawing and doing calculations and making decisions, you're always assuming what the people's values are. And what you end up with, if you're not careful, is a building at the end of it that actually the client didn't fit the client's values and didn't really fit the brief. And it's sort of highlighted here, values often remain implicit because people find them very difficult to express. It's actually very difficult to say what you value. It's quite easy to say it in numbers. You can easily say 1,500, and maybe that's why numbers dominate and economics dominate more than other aspects. But clearly, from what Hugh has shown, there's more than just the capital cost that's important in a building. Understanding it from a, would you like to work there, and is it good in the long term, and will the occupants enjoy working there and work productively there, are also important. And certainly for a school, those values are very important. So we try to establish the personal values and link them into project values. And we had a look at how this might work. Now, hopefully you can see some of this. We looked at a number of different measures, and we asked them, each of the different groups, what they thought was important. Now, take this one, for instance, have direct access to outdoors from all classrooms. The architect thought that this was number one. This is the most important aspect of the brief. The client and the teaching staff thought that this was the last thing that they needed. It was in the brief, but it was lower priority than some of the other aspects. The top one, offer more space, larger classrooms. The teaching staff and the governors thought this was absolutely important, but the design team didn't think this was an important thing, and neither did the management of the school. So you can see that there's different values, different things come out. Storage facilities, very high on the teaching staff perspective, relatively low from the management, from the design team. That's interesting, but what impact does it have? Think about it this way, from a sustainability perspective. If you have more space, then you might have better staff and a better student experience. But you'll have more heating, lighting, and maintenance, and so it will be less environmentally friendly. How do you make a decision over which one of those is the most important, unless you know the importance of relative values? And that's just one example. If you can imagine going through numerous ones of those for a design of a school, you need to really get an understanding of the balance between how people perceive value and what they think is important, and to understand the knock-on impacts of decisions. To do that, to inform that decision making and those value assessments, you can use tools like life cycle costing. And at the bottom there, we try and use something we call multiple criteria decision analysis. And that's where you set out the criteria under common themes and a numerical basis, and you assess options against those with weighted scores. And you try and create more informed decision making. So that, I think, is important for sustainable design. Now, take an example. Why is the iPad successful? What is an iPad? An iPad is one of the best examples of user-centered design. When buildings are designed, they're not often designed from the user perspective. They're often designed from a design perspective or from how it looks perspective. The iPad is not designed from a how it looks perspective. It's designed from a user perspective. What it is an excellent platform. It doesn't tell you what to do with it. You don't really know what to do with it. But what people do is they create applications, flexible applications, that then bring it to life. So the iPad itself is a platform. And in a way, that platform allows the user to adapt it and do whatever they want with it. And it becomes far more useful. And I would say that you couldn't imagine ever needing an iPad, but suddenly everyone buys one. And I don't really know its usefulness or its utility, but there clearly is one. But it would have been very difficult in the marketing brochures to say exactly what use it would be. And it's the applications, it's that platform you provide. And you need to think about buildings in a similar way, from a user-centered design perspective. We need to think about buildings as, how do you create a green building? Is it the design of the hard system? Is it the buildings? Is it the technology? Or do you also have to take into account this complexity of the soft system? Now, often people will design a building, they'll look at it afterwards, and they'll say, the users aren't using it properly. They're not using it the way I designed it. And that's perhaps because we didn't design it the way they would use it, for the way they would use it. So if you don't understand the complexity of the soft system, you're not going to get a green building out of it, no matter how good your design. And a good analogy is put a soft person in a very high-tech swimsuit, and they're not going to win you a gold medal at the Olympics. And we took an example of this. There was an eco-town designed by us in the UK, and we examined its energy consumption after 1 year. We went to every house, I think there was about 26 houses, and we went to every house, and we looked at their energy consumption in detail. Some houses, and for instance, these are identical for any other means, use half the energy from others. Well, what's the difference? The systems are the same, the building design is the same, it's in the same location. What's the difference? The people. So you can put a lot of emphasis on the design, but you've really got to follow it up with systems. And we sent another of our PhD students in afterwards who talked to the owners and the occupiers about how do they use their controls. Do they understand the control system? Can they program the heating? Do they know to turn off the lights? The people who were performing very badly didn't understand how to use the control system. Now, around the world, there's a lot of people who don't know how to use their control system. There's a lot of people who are at the right-hand side of this. If we can educate, go back into buildings and look at the way they're controlled, the way that they're used, we can halve energy consumption. Halve energy consumption. That's significant. If we look at the people and what people do, we can halve energy consumption. There's no other measure that you can think of that can do that. And just for instance, the rollout of energy meters, or smart meters within some regions around the world, have provided 10% to 20% improvements in energy savings. So that's a good example. And looking at how do users use buildings? Here's an example. In summer, very hot outside, all of the blinds are down. In the winter, very cold outside, all of the blinds are down. The users, from an architectural perspective, are not using this building the way it was designed. It was designed badly. It isn't designed for its environment. It's not designed for its users. And so it'll be very poor performing, it will have very high cooling loads. I won't touch on that. When we've looked at, research has been done looking at whether or not people are happy in buildings. And you'll find that actually the temperatures that people are happy and comfortable at range quite a lot, from say 21 degrees to 25 degrees in an air-conditioned building. But in a naturally ventilated building, they can be happier up to 27, 29, 30 degrees. And this is in a region, this was examined looking in a region in Southeast Asia. And this is something we need to challenge about what people feel is acceptable. Do they always want it at 20 degrees? Well, actually, if you look at if you interview people and ask them if they're cold, neutral, or warm, at 20 degrees, you've got a vast number of people who are cold. And even up to 24 degrees, you still haven't got, everyone agreeing. In fact, really, 24 degrees is probably the best in terms of a reasonable spread between the three responses. So go back to your offices where you work and find out in the summer what temperatures everything's controlled to. You can take this further. The thick bar on the left is one clothing value. So if people are wearing a normal suit at work, and the bar on the right is if they're wearing more casual clothes. And you'll see that people are more comfortable at higher temperatures, obviously, if they're wearing more casual clothes. But the dots show whether or not, the acceptability levels. So where there's a dark green dot, the majority of people were happy. Now, what those bands show, they are the assumed thermal comfort bands that we design all buildings to. They are the code, they are the regulation within ASHRAE to say this is what a comfortable building looks like. Actually, the science shows that people are comfortable outside those bands. We can allow buildings to increase in temperature beyond those levels. That's for an air-conditioned building. This is for a naturally ventilated building. And again, the spread of which people are happier and still comfortable in their environment is much greater than that demonstrated from the ASHRAE bands. And I tried to overlay these, but it didn't work. But you can see that this is the weather data for Istanbul. And actually, if you look at the yellow thing in the middle, that's the defined comfort band. But if I push back, you can see that people will be comfortable in their buildings even throughout the summer. Even in these areas, people can still be comfortable in naturally ventilated buildings, as long as they've got the right air movement and other factors. So if you design the building, you still need to design the building from a perspective of working in terms of passive design. You can't just turn off your air conditioning. That won't make people happy. But if you design it in the right way to passive design principles, you can do without air conditioning for many of these periods and do without heating for some of the lower periods. So there's been a push, and ASHRAE have created a new standard called adaptive thermal comfort standards, where you can where it recognizes that people's perceptions of temperature change throughout the year. Sorry. A lot of this is informed by, post-occupancy evaluation, going back into buildings. And this is really important to put that back into the cycle of design, using post-occupancy evaluation to inform design. We looked at 5 schools that were all designed to the same brief. They're all brand new buildings. And after 1 year of performance, they had very different performance levels. There are slight differences between the design technique that was followed and the solutions that were given, but the brief was all the same. Now, schools C and D, one of the notable things here is that those schools had a facilities manager who was educated. They had automatic control systems for lighting, and they had a facilities manager who went around the building and made sure things were off and that the building was looked after properly. And there's a significant difference in the energy consumption between those buildings. And you can see in particular the lighting consumption between School C and School B. And these are, say, pretty much identical briefs. The difference that things like lighting controls and having facilities management is significant. Post-occupancy evaluation could even involve testing such as this. So this is air pressure testing. This is actually in Abu Dhabi. And you can see, this is a smoke test, and you can see that this is a brand new villa, just finished, and is meant to be a green building. And the smoke is just pouring out of the gap between the window and the wall. This attention to detail after the building is finished and fixing that detail is absolutely paramount, because the rest of that building's life, it doesn't matter how you designed it, how you modeled it, if you've got that after construction and the contractor's not done what's needed, then you're going to have a very inefficient building for the rest of its life. So this is important, understanding that the building design is one component, but how it is operated, occupant behaviour, is absolutely probably a larger aspect. And getting into existing buildings, engaging the people, engaging the users in how they use their building, and then reducing the demands, and then changing the design. That's how you can make significant 50% or more carbon reductions. This is shown, this is one of the, at the time it was the highest efficiency office building in the UK, Wessex Water headquarters. And after 3 years of post-occupancy evaluation and feeding back to the facilities managers, to the owners, to the users, we halved the energy consumption. And at the end, only after those 3 years did it meet the design targets, because then it was being used the way it was designed. And the way to think about this is to understand what environments you want to create in a building, what functions you're going to take in that. Don't have every environment the same at 22 degrees, at the same lighting levels. Design your environments around the functions that people require. And you can design your functions around the environments within your building. So you can move the functions within the building around where the glazing is, where the sun is, and things like that. Get stuck into the people and understand how users will use the building and educate users. And then you can apply technology. But the big wins will be from the start. In terms of new building design, I mean, this is pretty common, but understand your energy benchmarks, understand the targets you're going for, understand what integration you can do in terms of resources, plan your systems efficiently, design your buildings with the right massing and orientation, think about occupant transition periods and comfort. Do you always need the same temperatures in every zone? And then think about the environmental strategy and behaviour influence, how your design can influence those people. Now, I realise we should be coming to an end, but this is the fun bit. So, we talked about integrated design, and what happens when we're trying to do design analysis and modelling, at the early stages of design, it's very difficult to come up with an accurate analysis. At the end of the design, you can do a very accurate model, but by then, you can't inform the design. You need to get accurate modelling and flexible modelling at the start of the design phase when you can make a real impact. So we've developed a tool, a holistic energy tool, which allows us to take a building and model every aspect of it very quickly. And there should be, hopefully this will work, and there's a demonstration of this. Click. Yep. Okay, so if you watch this, this is changing the glass from 100% glass down to 0% glass and then back again. And you can see that the carbon factor at 100% glass is much higher, and as you reduce it down, it goes lower, 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 and then it starts going higher again, because with no windows, you've got no daylight, so you have more lights on. And you can see there the impact of such that simple measure has on the heating, cooling, lighting, fans. And that can be done very quickly again. So we have another aspect here, looking at the depth of the zones within a building. So as you get a shallower building, it reduces, but then if you go too shallow, again, it increases. So there is an optimum, and you can optimize each of these values. Again, this is looking at the shading depths, and this will vary for every facade and depending on what other variables you've selected in the building. So this is looking at changing the depth of the shading and what impact that would have on the carbon emissions. And through very rapid prototyping, being able to change all of those factors and intermingle them, we can really inform architectural design to optimize the passive design right from the start and move on from that. And from that analysis, you can examine the impact from every single individual measure, so improving the glazing, from using the daylight, from reducing the lights to using LED lighting, and you look at every aspect in that way. I was going to talk about some example buildings, but I think I'll get shot. So this is a building which is a world first, and this has achieved the LEED Livable Buildings credit, the first building to go. It's not certified silver, platinum, gold or platinum. This is what we call a livable building, a living building. And this is designed looking at the wind flows, the orientation, a lot of detail analysis. And the key thing about this is when they've asked the students, do you like this building? They've all said, apart from one, and I want to know who that one child is, she was having a bad day, do you like this building? Is it a beautiful building? And they all said, yes. And that's the important thing. Oh, and it generates more energy than it consumes. And it's got a livable building credit, which is all requisites and no credit system. I'll slip on past this one. I wanted to talk about Marks and Spencer's because I know that they're active in the region. And we've worked with them to challenge, they've got a system they call Plan A. And they as an organisation are really committed to sustainable development. And when they committed to Plan A, their share price went up. Since they committed to Plan A, and it's cost them some money to change all of their stores, the way they do everything, since they committed to it, their profits have gone up. They are only seeing benefits from going green. And they're going so green that the profits have been so good that they want to go greener. They want to be the greenest in the world, and they will stop at nothing to get there. And I think that shows you that once you get on that path and you realise the benefits, that the value is there. So I'll just close up. Here are some examples of projects we've done or doing in the region. We're looking at the airport in Baku, where we're doing we've done a lot of daylight analysis. The Zorlu Centre, which I saw for myself today, which is being built. It's a Burhapur design. Skymark Tower and Variat Meridian, which I believe has achieved a LEED rating. And some projects in the region. So Pyramid Piece, the Star Stadium, I'm sure you're familiar with them all. And we've very much enjoyed working in the region and the interesting challenges it provides. So just in summary, there's a very clear need for sustainable design. I hope you got that message. I think I probably overdid it. Always try and understand the context. Don't just apply a photovoltaic panel and assume that's green design. Understand the broad context of what's needed from sustainability. Understand the stakeholder values and needs. Develop a bespoke vision if that's required. Use BREEAM and LEED, they're excellent, but also think about what's your picture. Apply integrated tools and thinking. Look for symbiosis, they'll save you money. Conduct detailed analysis if you can afford it, and if you need it. Employ that user-centered design thinking, and that's something I would strongly push. Consider future uses and adaptation and the future values, and close the loop of design and operation to include analysis of existing buildings. And that's it. Thank you for listening.
Evet, çok kısa olarak bir soru-cevap bölümü yapacağız. Dileyenler varsa el kaldırabilirler, arkadaşlarım var çevrede. Size mikrofonu vereceğiz. Yoksa da toplantımızı burada bitireceğiz. Sorusu olan var mı acaba? I guess there are no questions. Çok teşekkür ediyoruz. Thank you very much. Evet, başta ana sponsorumuz Arçelik olmak üzere sürdürülebilir yapılar ve iklimlendirme toplantısına katıldığınız için çok teşekkür ediyoruz. Bu yoğun günün sonuna kadar bizlerle oldunuz. En kısa zamanda görüşmek üzere. Herkese iyi akşamlar diliyorum. Teşekkürler.